Hello all you Murgetroid maniacs. Today's video I'm posting on my YouTube channel, which I encourage all of you to subscribe to. It'll keep you up to date on the latest developments of the Murgetroid. But I apologize that this film's a little bit longer than normal, and that's just because there was more information I wanted to get out. If you look down in the below the film here, you'll see a time reference that will show you if you want to jump right to the show, which uses the new cylindrical 3D coordinate system I developed. Go ahead if you so desire. Thanks for watching. Hello everyone. In my last video I talked about a new test space that was built, and to this video I'd like to discuss what I have done using this new test space and how well the new test space has performed. If you read in the comments, I'll give you a skip ahead if you want to look to see the new demo of the Murgetroid using some new techniques I developed with the test base. But in any case, I am happy with the new test base. It's much easier to program than the original configuration where the microprocessor was spinning. And this has allowed me to develop a new method of programming the Murgetroid, which generates different images. I'm not going to say they're better, but they're different than I've been able to do before. And I would not have been able to do this with the original configuration just because of the hassle of having to plug in and out the cable to the microprocessor that's spinning, and not being able to get real-time feedback from the microprocessor, and the fact that every time I programmed it, I'd have to stop the Murgetroid from spinning, take off the infinity structure, program it with the cable, pull the cable out, put the infinity structure back on because it won't spin properly without it, and then spin it up. So that's the reason for the test space, is to eliminate all of that hassle. In any case, in order to really understand what I've done with the new test space, you need to understand some of the limitations of the Murgetroid. And so let's first talk about that. There are basically two types of images that the Murgetroid can display. There's static images like you see here. This image wouldn't change over time, and it remains continuous as I rotate it. But there's also images that are created by flashing the outer edges of the panel very quickly. And by flashing the outer edges of the panel quickly, I can create non-symmetric images like text and moving spirals and things of that nature. So for example, if I just light the outer edges, if I just try and flash the outer edges of the panels, then I can flash as many as 72 times in a given revolution. However, if I try and flash all these LEDs at the same time, then I can only do 12 flashes in a revolution. That makes a very large difference in terms of how you, what the image you can generate. I've always had the capability of flashing the outer edges, and I use that when I do my text routines, and you've seen that many times. Also, I've been able to generate other images with that same text routine, but all those images scrolled along the outside edge of the display. What's new here is that what I'm able to do is specify 3D coordinates using cylindrical coordinates. And the way I do that is I specify an angle which represents the point in rotation at which I want the display to occur, and that's relative to the Hall sensor, which is over here. So this is angle 0. This would be like 90 degrees, 180 degrees, 270, and once again back to 360. So I specify the angle, which says which point in time I flash. I specify the radius, which is the distance from the center of rotation. I specify the radius, and I specify the height, the z. So by those three coordinates, I can light any LED at any position in time. In order to better illustrate the resolution capability of the Murgetroid, I created this short demo which has two 3D coordinates, cylindrical coordinates, one over here at 0 and 90 degrees, connecting up to 270 degrees and the top. And each time the color changes, I'm changing the number of LEDs that are capable of being flashed.
And this has an effect on the quantization of the line that's being drawn. You can see that as the number of LEDs increases, that I'm capable of flashing increases, the resolution decreases. For example, this is with just the outer column. Look how nice and smooth that red line is. But as I increase the number of LEDs capable of being flashed, which you can see by that yellow, as that yellow gets more depth to it, the number of LEDs I'm flashing is greater. And as that occurs, you can see that the quantization of these lines that are connecting up here gets wider and wider and more of a staircase. And that's the basic limitation that occurs due to increasing the number of LEDs, which slows down the flash rate, the number of flashes in a revolution. So the Murgetroid spinning up. These are the images I created using the new 3D coordinate system, cylindrical coordinates. This is each one of these images that you're seeing started out as a test structure, and I've embellished it to make a more interesting show. These are demonstrating different aspects of the 3D coordinate system that I talked about. You'll notice everything is flashing. That's because it's the way this system operates. LEDs flash at specified points along the rotational axis relating to the angle. When I talk about angle, I'm talking about 0 to 360 degrees, and I break that into the number of flashes that I can get in one full rotation. As I mentioned earlier, that depends on the number of LEDs that I've got lit. Some of these images were inspired by friends requesting different things, like this one here. My friend asked if I could generate an image where parts of it were rotating in opposite directions, and I did that. It didn't show as clearly as this particular one does. You can see the blue and red are rotating in opposite directions. There's also a minor bug there that I need to address. You know, some of the challenges in this whole process is the fact that in order to minimize the strobe effect, I had to light both edges of the panel, but each edge had different data, and so that was one of the many challenges I had to deal with. Here I'm just shifting two coordinates. I basically had two coordinates that was shifting in the last one. Actually the one at the top was the only one shifting. Here a friend challenged me to make cube, and I have cubes here that you can see floating in space. I mean, there's as best I can do given the limitations of the resolution of the Murgetroid, which is very limited. It's it's just a very limited. Here I'm got different spirals, inner and outer, rotating in opposite directions, and once again showing how I'm basically just setting out 2 points that get dragged along. It shows repeating at this point, and this image also shows that I was able to animate the inner and outer of the Murgetroid. Here I'm increasing the number of LEDs each time. I'm eventually going to have all LEDs being able to be flashed, and when I do that, the flash rate slows way down, which is why these lines look so thick. That's because the flash rate when I have all LEDs involved is much slower, as I talked about earlier. In any case, the images I'm able to create with this are interesting and fun to do. I would say they're just as interesting as other images I've created previous, but having a new technique to be able to make new shows is always a good thing. And even though it took a lot of energy to get it to this point, I mean, my goodness, it was very complicated. Many things went wrong along the way, and I enjoyed fixing every single one of them. In any case, I hope you enjoyed this show.
So I have a few more points I'd like to make before I end this video. I wanted to mention that every time I flash the Murgetroid LEDs using the cylindrical coordinate method, I basically am doing two calculations to decide which LEDs get turned on and which colors. The two calculations are one for each edge. The outer edge, or each edge as it rotates, has a different amount of data, different data on it, and each edge therefore has to have a different calculation as to what LEDs get lit. And the two edges reinforce each other, so when one edge gets to the position that the previous edge was, it has to have the same data flashing. Otherwise, I see bad things happening on the display. I see jitter, I see different images between the two edges, and I really want the edges to reinforce. In any case, after I flash the image, there needs to be a very short wait just at the end of the rotation in order to resynchronize the display with the Hall sensor, which is at one point in time. And if I don't synchronize properly, or I miss that synchronization point by not waiting properly, then what happens is I have to wait an entire revolution to resynchronize. And that during that revolution, the display is blank. So what you end up with is a pulsing of the display, which is very disturbing, strobing, drive you nuts. So I spend lots of effort and energy to avoid that situation. And I've developed lots of techniques for doing that. The final thing I'd like to mention about this is, though I really love programming with the new base and the Murgetroid microprocessor being static, it's doubtful that if I build another Murgetroid for show, displaying the images, that I will use a static microprocessor in the base. And that's because I've been observing random LEDs flashing on the display. And these LEDs have not flashed before. It's only now when the microprocessor is static. And I think it's because the signal controlling the panel LEDs is routed through the slip ring in order to get to the panel. And I think there's still noise being picked up in the slip ring, or maybe the contacts of the slip ring aren't 100% all the time. But I do see these random LEDs flashing, and that's disturbing enough that I will continue to probably rotate the Murgetroid microprocessor for any future Murgetroids I develop. Thank you again for watching. I know this has been a longer than normal video, but I had a lot of information I needed to share. See you next time. Bye-bye.